Alright, today's lesson, we're switching gears away from distributing and multiplying. We're going to be talking about graphing radicals. And we're not going to do transformations yet. We just need to learn about the parent functions. Now we know the parent function for x squared. The parent function for x squared was 0, 0, 1, 1, 2 squared is 4. If I wanted to do another, 3 squared would make 9. My y chart is what I'm making. And then we also had the negatives of those. Negative 1 would become positive 1. Negative 2 squared is also positive 4. And we made this parent function where I went from 0, 0, 1, 1, 2, 4, mirrored it on the other side. We did that earlier this year. Parent function. Okay? Much as I hate graphing on this whiteboard, but you get the idea. What is the square root look like, though? Now, there's two concepts here. First of all, the square root is the inverse of x squared. So if I was doing 0, 0, 1, 1, 2, 4, 3, 9, taking x and squaring it to get y. 3 squared is 9. The inverse, as we'll learn later, means that x and y switch places. So the square root of x would be 0, 0, 1, 1, 4, 2, 9, 3, not 3, 9. X and y end up switching places. And think about that. I'm taking the square root of x. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. So 0, 0, 1, 1, 4, 2, 9, 3, 16, 4. Those are the parent function points for x, the square root of x. Okay? Now notice I didn't do any negatives. Why would I not have negative 1 as an x value, or negative 2? Well, you know why. We cannot take the square root of a negative. So if x is negative 1, it's imaginary. It doesn't exist. Which explains why, look at the graph, I only have so far. There is nothing in the negative direction. Nor is there anything down below. Now, if I were to mirror what I have, take what's in blue here, take this graph, and mirror it on the underside, that would be negative square root of x, because I took the square root of x and flipped it. But I can't have both. I can't have both parts, because if you draw a vertical line, it doesn't pass the vertical line test. That's non-functional. So what we really have for the square root of x is here's a parabola. That's x squared. The square root of x is a sideways parabola, but it's only half of the sideways parabola. Half of the sideways parabola. So the parent function for square root of x, here's our charts. 0, 0, 1, 1, 4, 2, 9, 3, 16, 4. Why am I using these x values? Because those are perfect squares, and I want to take the square root of x. So why wouldn't I use the perfect squares for x? So instead of your x values being 0, 1, 2, 3, it's your y values that end up being 0, 1, 2, 3. And again, these are inverses, so the roles of x and y switch places. It's y that goes from 0, going by 1, 0, 1, 2, 3, 4. It's the x values that follow the perfect squares. Okay? You need to know these. So we don't always use 16, 4. And these should be easy to remember. It's the first 4 perfect squares. 0, square root of 0 is 0. 1, square root of 1 is 1. 4, square root of 4 is 2. 9, square root of 9 is 3. And I could keep going. 25, 5, 36, 6. But we're not going to get that big. We're not going to graph that far. And you can use 16, but we don't always use it. Now let's talk about the parent function for cubed root. Cubed root, odd root. Yeah, I'm allowed to have a negative inside of an odd root, so I will have negatives. So 0, 0 is the starting point for these. 0, 0. 0, 0 is also the starting point for cubed root, but it's in the middle because I can go both directions. So I start with 0, 0 in the middle, and let's think, what are the first perfect cubes? 1. Cubed root of 1 is 1. 8 is the next perfect cube. Cubed root of 8 is 2. If I wanted to do another one, I would do 27 and 3. 64, 4. 125, 5, the perfect cubes. And we're just going to go up to 8. And we have to do it in both directions, because I am allowed to take the cubed root of a negative. Cubed root of negative 1 is negative 1. There's your point. Cubed root of negative 8 is negative 2. So what we need to know for the cubed root, start middle is 0, 0. We go 1 and 8 in each direction, perfect cubes. And now look at y. Y goes by 1s. Just like before when we were graphing last semester, didn't we make the x values go from negative 2 to positive 2? We always use those numbers. It's now the y values that are going negative 2 to positive 2. And it's now the x values that are following the perfect cubes. Why? Because these are the inverses. X to the third and cubed root of x are inverses of each other. Okay? So, lots of ways to memorize this. You need to find a way to know your parent functions, to have your parent functions memorized. I think the easiest thing is x is the perfect squares or perfect cubes. They're the perfect numbers to match whatever we're working with. And I can do the same thing with x to the fourth root of x or fifth root of x. And the y values go by 1s. The starting value is 0, and they go by 1. All right, so how are we going to graph? Now, we're going to deal with transformations. But for now, we need to look at these in terms of the vertex. We've seen this before. In fact, we saw this in terms of x minus h squared plus k when we did these with quadratics. Well, it's no longer squared. It's now the square root. But it's still x minus h inside the square root. K is outside. A is outside. And we'll get to those transformations, but for now, we know that we always have to start our xy chart has to start with the vertex. And the vertex is always h comma k, just like it was earlier this year. H comma k. All right, so let's take a look at how this plays out. So in this example, I'm looking at graphing this. Identify the vertex, h comma k. We do the opposite of what we see for h. That's negative 5 comma negative 3. That's my vertex. So my square root function is going to start at negative 5 comma negative 3. And it's going to go up half of the sideways parabola. So let's see if we can fill in a chart to make this work. I'm starting at negative 5, and I know that my pattern is 0, 1, 4, 9, 16 if you want to. That's what it follows. So if negative 5 is now my starting point, I'm going to go, now I'm down here in this chart, I'm going to go up by perfect squares. See, in the last semester, if negative 5 was our first value, we would just go up by 1s. We're not going up by 1s. It's the y values that go up by 1s. The x values go up by perfect squares. So I'm going to go 1 away, go up by 1 away from negative 5. That's my starting point. I'm going to go 4 and 9 away. 1, 4, 9. 1 away from negative 5, 4 away, and 9 away. Another way to think of it is that this is going to be negative 5 plus 1, negative 5 plus 4, negative 5 plus 9. I'm adding the perfect squares to my starting value. It gives me these values. Negative 5, negative 4, negative 1, positive 4. And now, I don't expect you to plug these in. You can plug these in by hand into your original function. Plug negative 4 in to x and try to do this in your head. You can use the table app. Go to the table app, punch this in, put negative 4 in. When you plug negative 4 in for x, 2 times negative 4 plus 5 minus 3. And you run that through. I get 1 inside. Square root of 1 is 1 times 2 minus 3. I get negative 1. Run negative 1 through. Run 4 through. And you can use the table app to get those y values. I have my 4 points. Negative 5 comma 3, negative 4 comma 1, negative 1 comma 1, 4 comma 3. One thing to note here, your a value was 2. It said y equals 2 times the square root. Look at what your y values are going up by. Starting at -3, the y values go up by 2 because a was 2. So there's patterns to be found here. So again, to recap, starting from this vertex, -5, 3, these go up by perfect squares. Add 1, add 4, add 9, add 16 if you want to. These are going up by what a is. And then you need to graph it. So we'll graph these using that chart. And you can see, here's my points. -5, -3, -4, -1, -1, 1, 4, 3. And then draw it. Now, be careful when you're drawing these. It starts here at the vertex and goes up. Do not let anything get below that vertex. You draw a line down there, I have to mark it wrong. It starts here and goes. There's nothing before it this way, and there's nothing below it this way. There's nothing there. In fact, the domain and range will never be infinity to infinity for these. The domain goes from -5 to infinity. The range goes from -3 to infinity. There's nothing this direction. Okay. And if you can get that down, then the cubed roots should be just as easy. Cubed roots are basically the same thing. I look at this graph and I identify the vertex is +2, +1. Do the opposite of h. So, and again, I can go both directions with cubed root. So I put 2, 1 in the middle. It's my middle point. And now I'm going to go by perfect cubes in each direction. I know the perfect cubes are 1 and 8. So I'm going to go up 1, and then from the middle go up 8. Add 1 and add 8. This way I'll subtract 1 and subtract 8. Go 1 and 8 in each direction off of the center. Now what are the y values are going to do? We'll look down here. Look at the y values. The y values are going to do exactly what we think. There's no a value in front other than 1. So look, the y values go by 1. -1, 0, 1, 2, 3. So from this center of 1, I know I'm going 1 in each direction. I don't even need the table because I know the pattern. Now, if you're not sure, go ahead and type these into the table. Enter in this function. Put these 4 values in. Maybe in this one just to check it. And then you'll see, but you'll see the y values go up by 1. So it's not always necessary to do the table F if you understand the pattern. And then I would plot these points. Here's my 5 points. -6, -1, 1, 0, 2, 1, 3, 2, 10, 3. Now this does go in both directions. So I'm allowed to do, whoop, arrow, comes down here, whoop, arrow. This looks an awful lot like x to the 3rd. We graphed, oh that's terrible, I hate graphing on this thing. It goes up, comes like this. Isn't this the wiggle that we saw with x to the 3rd? It's that same wiggle, only it's been flipped sideways. These are inverse functions of what we did earlier, so they've been flipped sideways. Okay? Alright, you're graphing 4 of these. 2 square roots, 2 cubed roots. Follow the patterns, look back at the notes to help you.